let's get this triangle sketched out. So we've got a 120-degree angle. Okay, it's going to be quite a large angle. So see, that looks a bit too equilateral. So maybe something like that. Therefore, this can be BC is 3, and then A here, so this is 5 and 7, and ACB is 120 degrees. We're told that the area of the triangle is M. What's the value of M squared? So ideally for this, you'll know the formula that the area is a half AB sine C. And if you didn't know that, well then I think it's worth learning at this moment, and I will derive it at the end. Because then all we have to do is substitute in half. A is going to be like opposite the angle A, so that's A, so it's a half times 3. This is little b times 5. I should have said that. So the lowercase b is opposite the uppercase angle, and that's the same for all the sides and angles. And then I'm times and by sine 120. Okay, this does require us to know some of our exact trig values. So here's the sine graph. Sine 120 is exactly the same as sine 60, because this one is 60 away from 0, this one's 60 away from 180. Both positive. And sine 60 is root 3 over 2. So I've actually got 15 root 3, because 3 times 5 times root 3 over 4. That's going to be my area, M. Therefore, M squared is going to be 15 squared, which is 225, times root 3 squared, which is 3, divided by 4 squared, 16. And that gives me 675 over 16. I'll do a little division. You could keep halving it, but you'd have to halve it 4 times, so probably best to just do a division. 16 times 4 is 64. Leave me a remainder of 3, so we're going to get 42, and then the remainder 3, so 42 and 3 sixteenths, which to the nearest integer is going to be 42. Therefore, answer is 0, 4, 2. Brilliant. All right, let me show you where that comes from. It's worth learning how to get this. Actually, quite a simple process. I'm just going to draw a triangle, just a general triangle. Although it's got to be said, I've made all the angles acute here, but you can extend it to obtuse. I'm just going to do a proof for acute. I'm going to say that this angle here is capital C, so this is C. I'll say that this is capital A, so this is A, and this is little b. Right, well, what I can actually do is draw a perpendicular coming down from A. And that's going to be my height. And then I can use this triangle on the left, this right angle triangle, to write down that sine C is actually h over b. So h is in fact b sine C. And then the area is a half base times height, is a half times A times h, or a half AB sine C. Okay, this does extend to obtuse angles. You can use it so basically if you have two sides and the angle in between, you use this approach to work out the area of a triangle rather than your normal half base times height. Just going to share a very novel way of doing this question that avoids trigonometry completely, and it's all about that 120-degree angle, in fact. So what we could do, and by the way, I'd never have thought to do this, but extend BC. I know it's not drawn accurately, just please remember that, to create a 60-degree angle here. And if I just go the same distance, go above A, then actually this will necessarily give me an equilateral triangle. These will all be 60. And what we can then do is work out, do you know what, I'm just going to delete, there's a bit too much going on. Delete them. I can draw the perpendicular from A to this line. So that will be at 90 degrees. Because this is equilateral, well, we've got this length 5 at the bottom, like this length is, sorry, this is 5, and then this is going to be 2.5 because this perpendicular is going to split the equilateral triangle into two. So I can do 5 squared minus 2.5 squared. I'll call this, I think in the marks going to call it this, I'll call this AD. So AD is going to be 5 squared minus 2.5 squared and square rooted. That's 25 minus 25 over 4 because 2.5 is 5 over 2. Which is going to be, so this is actually 100 over 4. It's going to be 75 over 4 square rooted. I'll just leave it like that for the moment. I think I could maybe simplify it, but we're going to be squaring everything in a minute anyway. So if I want to now find the area M, then I just need the base times the perpendicular height. And that is precisely, this is the base. It's a half times 3 times my perpendicular height, which is all the way over here. It's just, you kind of have to almost turn it, let me turn it around. So you turn it around to this, and then you can see that the 3 is the base, and that's root 75 over 4 is the perpendicular height. So I just now need m squared. Square each term, so a quarter times 9 times 75 over 4. Well, 10 times 75 is 750. So 9 times 75, just minus 75 to give 675. And we're back to 675 over 16, which is precisely what we got before over here. I really like that. It's like a way you could do the question without ever having studied trig even. It just requires that very like, or that kind of out of the box thinking to draw this equilateral triangle.